Okay, we're going to be talking about percent of change today. So if you'll do me a favor and go ahead and get these notes written down, and then we'll go ahead and talk about it. So if you need to, pause the video. Okay, so percent of change, what's going to be happening is you'll be given an original amount, and then that amount is going to change, and so you're going to be giving a new amount. And what you want to do is you want to figure out the percent that amount has changed. It's either going to be a percent increase or it's going to be a percent decrease. Now, this is going to involve proportions, because if you look at this formula right here, markers sometimes works. If you look at that right there, that is a proportion. So if you do not know proportions, if you haven't dealt with proportions yet, please go and watch the video on proportions and then come back to it, because otherwise it'll be very confusing. Okay, so let's go ahead and see what we've got. Let's look at the first example. Let's say that there were originally seven children that were on the playground. And then when you took a count, there were 11 children on the playground. Did the number of children on the playground increase or decrease? Well, the number of children increased. Originally there were 7 and now there are 11. So we know that whatever percent we find is going to be a percent increase. Okay? So what we're going to do is we're going to take the difference, which you've got this in your notes, over the original, and we're going to set it equal to x over 100. Because the reason we're setting it equal to x over 100 is because every percent is out of 100. So the minute we solve for x, we can go ahead and make that a percent. Okay, so let's see. Well, what is the difference between 7 and 11? It's 4. And you don't have to say a positive 4 or a negative 4, because we're dealing with whether or not it's an increase or decrease up here. So the difference between 7 and 11 is 4. Now, what was your original amount that you started with? 7. So you're going to set that equal to x over 100. Now that forms a proportion. So you look to see, is there any kind of a shortcut? Well, no, because 7 doesn't go into 100 evenly. So what can you do? Cross multiply. So you're going to get 7x is equal to 400. And what we're going to do on these is we're going to just round to whole numbers, okay, if they don't work out. So we don't, because we're not really going to be we're not worried about learning how to divide or learning how to round right now. We're just rounding to whole numbers. Okay, so let's go ahead and divide both sides by 7. So you're going to take your 400 and you're going to divide by 7. Now remember, we said we're going to go to the whole number, so what we need to do is after we get to the 10th place, we can stop if we need to go that far. All right, so does 7 go into 4? No. 7 goes into 40 5 times, and that's going to leave us 5. Does 7 go into 5? No. So we're going to drop that, and we're going to get 7, and that's going to leave us 1. Now, we can't stop yet because we're rounding to the nearest whole number. So 7 doesn't go into 1. Well, how many times does 7 go into 10? 7 goes into 10 one time. Now we can stop. We want to know, is this a 57 or 58% increase? Well, we're rounding the 7. The 1 is not big enough to tell the 7 to go up. So this is going to be a 57% increase. We started with 7 children on the playground. We ended up with 11, so we had a 57% increase. Okay? All right, so now let's go ahead and do another example. And so let me go ahead and get this on the board. All righty. Let's say that we originally had 35, and now our new number is 23. Okay? So we had 35 of something, and now we have 23 of something. And we want to find the percent of change, and we want to round to the nearest whole number. Again, because we're just learning the concept, so we're not going to take it to the thousandth or anything like that. So we're rounding to the whole number. Okay, so we're going to find the percent of change. Did our number go up or did our number go down? We originally had 35, now we have 23. So our number went down, so we know that this is a percent decrease. Okay, so now remember we're going to use that formula, and I'm kind of writing it over and over again just so that it kind of sticks for you. Difference over original equals x over 100. That's the biggest thing that you have to remember out of this lesson. Okay, so what is the difference between 35 and 23? Well, the difference is 12, and you don't need to put a negative 12 because it's going down, because we've already taken care of the fact that we know it's going down. So the difference between 35 and 23 is 12. What's our original number? 35. Now we're going to set it equal to x over 100, because remember that's how it forms a percent. Anything over 100. Okay, so now 35 and 100, I don't see a shortcut, so I'm going to have to say 35 times x is equal to 12 times 100. So 35 times x is equal to 1200. So now we need to get the x by itself, so we're going to divide by 35. Okay, so now let me make some room over here, and let's do 1200 divided by 35. Okay, whole number, so we're going to go ahead and just put that upstairs. 35 doesn't go into 1 and it doesn't go into 12. Well, 30 times 4 is 120, so 4 is going to be a little bit too much for 35. So let's look at 3, and that's 105. So that's going to leave us 15. Well, 35 doesn't go into 15, so let's drop that down. So let's look at 35 times 4. 20, carry the 2, 3 times 4 is 12, so that would be 140. So we're going to have 34. Now, we can't stop because, why can't we stop? We don't know if it's 34% or 35%, okay? So what we need to do is bring this down. Now we know 35 times 3 is 105, so we know this is going to be a 2. So we can go ahead and decide, is this 34 or 35%? Well, you're rounding to the whole number. The 2 is not big enough to tell it to go up. So this is a 34% decrease, okay? So what we did is we took our difference over our original equals x over 100. This formed a proportion right there. How do you solve proportion? You just cross multiply. Okay, let's try another one. Okay, let's say that we had, I've got several written here, original of 61, and then the new number is 53. Okay, so original of 61 and a new is 53. Okay, now, did our number go up or did our number go down? We originally had 61, now we only have 53 of something, so this is going to be a percent decrease. Okay, so now what we need to do is remember our formula. Let me kind of write it up here a little bit. Sorry, not new. Difference over original equals x over 100, because we're trying to make it a percent. So what is our difference between 61 and 53? That's just 8. Okay, so we're going to get 8 over our original number, which is 61. Remember, the rookie mistake is right here. People forget, unless you just make a little math mistake, but the rookie mistake in setting it up is sometimes people will put the new number. So if you just got to remember, it's difference over original equals x over 100. Original, original, original. Okay, so now I don't see a relationship between 61 and 100, so that means I have to use my cross products. And we talked about that a lot with proportions. So we're going to get 61 times x is equal to 8 times 100. And for the sake of space, I'm just going to go ahead and say 8 times 100 is 800. We need to get the x by itself, and since they're multiplied, we're going to divide in order to undo that relationship. So now we're doing 800 divided by 61. Okay, since 61 is a whole number, we go over here and find our decimal, kick it upstairs so we don't lose it somewhere in the problem. So here we go. Does 61 go into 8? No. Does 61 go into 80? Yes, it goes one time. Okay, so now that's going to leave us 19. And I have to make a mess of this problem, but 10 minus 1 is 9, and 7 minus 6 is 1. Now 61 doesn't go into 19, so we drop a 0. Well, we know 60 times 3 is 180, so what is 61 times 3? It's just 183. That's not a decimal, that's just an errant marker. So 3 is going to give us 183. So now we're going to get 7. Now here's the deal. Are we done? No, because we're rounding to the nearest whole number again. So what we need to do is bring down a 0, and then we need to see, okay, well 61 goes into 70 one time. So if we're rounding to the whole number, are we closer to 13 or 14%? Remember, when you round, this is what we're rounding to, the 1. If it's 5 or more, it would tell the 3 to go up, but because it's 4 or less, it's just going to be a 13% decrease. Okay? Now, there are a couple things I want to mention here, and then we're just going to do 2 word problems and wrap it up. But remember, when we did proportions, there were frequently times where you would find a shortcut, and sometimes I refer to it as a cheat, but it's just a shortcut. It's not like you're cheating off someone's paper. Okay, so if we originally had 25 and our new number is 21, if you notice, our difference is 4, our original is 25, and we're setting it equal to x over 100. Well, if you notice, there's a relationship here, and so you just carry that upstairs, and you're going to get 16%. So this was a 16% decrease because our number went down. Okay, so this problem was really quick because it had a relationship, okay? There was a shortcut that you could take. And I want to show you another example of a shortcut. Let's say you had original of 10 and your new number was 17, okay? All right, so your original number was 10, your new number is 17. So the difference is 7. Your original is 10, and you're setting it equal to x over 100. So now you could always do the cross products, but if you notice, there's a relationship here. Times 10 times 10. 7 times 10 is 70, so this is a 70%, and it is an increase. Okay, so make sure that you watch for those type of relationships. If your original number will go into 100 evenly, and so that would be, of course, 1, 5, 10, 20, 25, 50. Those numbers go into 100 evenly, so watch for those because they make your life a lot easier. Okay, so here we go. There were 21 students enrolled in biology for the 3rd period class. By the end of the semester, there were 29 students in the class. Find the percent of change, round to the nearest whole number. Okay, so what was our original number? Our original number was 21. Okay, now by the end of the semester, our new number is 29. So first of all, is that an increase or a decrease? Well, that's an increase. Okay, so what is the difference? 8. And how many did we originally have? Was 21. So this is our difference over original equals x over 100. So we're going to say 21x is equal to 800. Okay? We're going to divide by 21. And so we're going to get 800 divided by 21. And I'm going to go ahead and make room here. So 800 divided by 21. Okay, so 21 doesn't go into 8. Well, 20 times 4 is 80, so we know where 21 times 4 is going to be too much. So this is 63, and so that's going to leave us 17. And I'm kind of doing some of this math without writing it out just because I'm running out of room. 21 doesn't go into 17, so we need to figure out how many times does 21 go into 170. Well, 20 times 8 is 160, so let's see what 21 times 8 is? And that's 168. So we're going to go ahead and put this here, if I can fit it in, and that'll be 168, and that leaves us just 2. 21 doesn't go into 2, so we drop our arrow. 21 still doesn't go in, so that would be a 0. So since we're rounding to the nearest whole number, this is just a 38% increase, okay? So all we did was we took our original number, which was 21, and then our new number was 29. We took the difference, and then we set up our difference over original equals x over 100. Okay, one last. The 5th graders are going on a field trip. Well, they had 48 signed up to go, but on the actual, that's an actual, my L hit the road, the actual day of the trip, only 43 participated. Find the percent of change to the nearest whole number. Okay, so our original number was 48, but our new number, the ones that actually went, was 43. So we want to find the percent of change between how many signed up to go and how many actually went. Well, our difference is 5, and our original is 48. So we're going to set it equal to x over 100, and then we're just going to do our cross multiplication. So 48 times x is equal to 500. Okay, so let's do 500 divided by 48, and we're not moving any decimals because we're dealing with whole numbers. Okay, so 48 doesn't go into 5, and it goes into 50 once, and that leaves us 2. Well, 48 doesn't go into 2, so we're going to drop our arrow, and that's 20. Well, we brought a number down, it still didn't go in, so we had to put a 0 in our quotient. Then we're going to drop another 0, 48 into 200. Well, how many times does 50 go into 200? 50 goes in 4 times, so let's try 48 times 4. 32, and that's 192. So now we need to decide, is this 10 or 11%? And the 4 is not big enough to tell the 0 to go up, so this is just going to be a 10%, and this was a decrease between the number that signed up and the number that actually went on the field trip. Okay, so that's percent of change. The biggest thing you need to know is difference over original equals x over 100, and then how to solve proportions.